Fix my camera. Hello everyone, today we're going to be solving another word problem regarding addition of vectors. Now this is the sixth video or sixth problem about it. Find the resultant vector of two forces, one with the magnitude of 155 pounds in a direction north 50 degrees west, and a second magnitude 305 pounds, they're in direction south 55 degrees west. Okay, so for this problem, we have another representation of the cardinal directions. Basically, another way to represent our angle on the Cartesian coordinate plane. But don't worry, we're going to tackle that as well. So number six here. Find the resultant vector of two forces, one with the magnitude of 155 pounds. Okay. So 155 pounds north 50 degrees west. Okay, so this is another way in which we can represent the angle and direction of our vector. On our previous examples, we've had south of west, north of east, and all that, but this one is north 50 degrees west. This is actually slightly easier than the last one, which involves words. But this one, it's just the direction and the symbol of the direction. So now, okay, so we're gonna try to find the angle of the thing first, or the vector first rather. So north, okay, we start with north. Okay, this is our north here, 50 degrees west. So 50 degrees west, which one here is our west, this or this? Obviously this, right? So we go boom, and since it goes from here to here, this is gonna be our angle now, 50 degrees. So that's gonna be 50 degrees west with the magnitude of 155 pounds. For our other vector, we have 305 pounds in the direction of south 55 degrees west. So south 55 degrees west. Oh, don't forget the symbol. I forgot the symbol. In the second line, 305 pounds in direction south 55 degrees west. So we could actually just either just attach it here, but I prefer to use a separate Cartesian coordinate plane for this one to make it more organized. South 55 degrees west. So south 55 degrees west, we're gonna start from south here, south 55 degrees west. Which one here is west? Is it this one or this one? Obviously this one. It's just W, so it's west. W. So 55 degrees there, and bam, 55 degrees with a magnitude of 305 pounds. Now we head on over to the analytical method, where we find the opposite and adjacent sides of our vectors. So now let's result to this one first. So always remember that the angle must start from the first quadrant, obviously the east axis here, so here to here, up to the resultant vector. So if we know that this is 90 degrees here, this is 50 degrees, what should be the total angle from here to here? Obviously 90 plus 50 is 140, and even if I check it in my calculator, 90 plus 50 should be 140. Yes, 90, so 140 degrees here. So the format of the cosine and sine formulas, cosine and sine formulas for the x and y components would be the magnitude 155, cosine the angle, 155 sine the angle. That's it. Substituting those into the formula, into the calculator. 1 cosine 140, negative 118, negative 118.7369, sine 99.6321. So now representing that into vector components, negative 118.7369, 99.6321. That would be the component form of our first vector. Now we're gonna try to find the component form for our second vector. So this again is 55 degrees. So starting from here, it's 90 degrees, up to here 180 degrees, up to here 270 degrees. So if this total portion here is 270 degrees and this small one here is 55 degrees, this is our unknown angle here, this one. Let's call this angle theta. So now theta, this plus this angle, which is 55 degrees, plus theta should equal 270 degrees. How do we solve that? Just subtract both sides. I like to do the analytical method. The algebraic method. Then having fixed formulas for it, because it's more universal rather than having fixed formulas. So I do that method instead. So 215 degrees for this one. So again, use the format magnitude, cosine, angle, magnitude, sine, angle. So our magnitude 305 cosine angle, 305 sine angle. It would be, I'm just gonna use my calculator for this one. Sine, cosine, negative 249.8414 sine negative 174.9408. So presenting that into a vector component would be this, like this, 204.814 174.9408. So now we're gonna add the x components and the y components together. No. So I'm gonna do the y components first, because it's already inputted on my calculator and all I have to do is add 99 to it. So yeah, 99.6321 negative 75.3087. Wow, 75.3087. Our other one, which is negative 249.8414 plus negative 118.7369 is equal to negative 368.5783. Pardon my handwriting. So now we're gonna use the Pythagorean theorem. Negative 368.5783 squared plus 75.87 squared is equal to, let's move this paper first. So substitute it here. Oops. 368. Negative 75.375. I wrote, oh yeah, I accidentally typed 25. I'm just gonna double check, because a while ago I had something wrong. Whoops. Yeah, and look, I did have something wrong. No, that's why I had to double check. It's 368, not 365. So now our final resultant vector should be 376.9333 pounds. And that's it. That's the resultant vector of the two vectors now. So now we're gonna try to find the angle. Now the angle is gonna be pretty easy. Now using the butterfly method again. Okay, here, negative, that would be the fourth quadrant. Now referring to the butterfly method, the angle that we're going to be finding is here. It's this angle here. Now I might be wondering, why are you even doing this? You know, because if we know where the angle is, or what quadrant it is, and it's specifically what it looks like, we're going to know exactly how to find the angle here, starting from here up to here of the vector. So now, using our formula tangent, negative 1, y-axis, which is negative 78.3087 all over negative 368.5783 is equal to 3087. I'm going to use my calculator for this one. Negative 368.5783. 11.5475 degrees. That's not our final answer yet, because it's that angle. We need to find this one. The same method we used to get this angle here. So 11.54785 degrees plus theta should equal to 360 degrees. So 360 degrees minus 11.574547 rather 85 degrees is equal to 348 degrees. 547, yeah, 348 degrees. 0.45215 degrees. So yeah, that's our answer right there. I don't know if you guys can see it. Yeah, that's our answer. Our final resultant vector, 376.1933 pounds, and for our angle, 348.45215 degrees. Thank you for watching.